Chapter 6, Section 1. Let's talk about vectors. We're going to start from the very basics. We're going to start from the very beginning. We're going to introduce the idea of what a vector is. How does a vector play a part in all those topics that we had written on the board a minute ago. And so let's look at just a vector by itself. If you have a vector has what? Magnitude and direction. It has a very specific way I should go, a direction, an angle. And it also has a length, which we call magnitude. A vector by itself looks like an arrow. Okay? That arrow is fixed. I'm not just arbitrarily drawing at a specific length. The longer the arrow is, the more its magnitude. In physics, this is used for forces. If you ever watch the Weather Channel and they talk about the vector fields when they show tornadoes or wind patterns, you'll see little tiny arrows in a direction. Sometimes those arrows are really small. Sometimes those arrows are really long. Okay? The little tiny arrows mean it's a weak force. The wind isn't very strong. But when that arrow gets really long, it's telling you that it's blowing in this direction, and the force is whatever that magnitude is. And so that's kind of a practical application. If we look at the vector by itself, a vector is composed of 4 parts that we're going to talk about. The first part, you have the horizontal component, which is called the x component, and the vertical component called the y component. Component form looks like this: x, comma, y. Notice the pointed brackets. Do not write a vector with parentheses. If you use parentheses, that's a point, not a vector. Okay? So if I did this, well, this is a point. And yes, that's a big deal. That's a big, big difference. If you told me here's 3, 2, in terms of parentheses, that's exactly a single dot at a very specific location. But if you told me vector 3, 2, then you're telling me, okay, I want you to go 3 in the x direction and 2 in the y direction. That's telling me where to go and how far to travel. That's a very, very different piece. And so make sure that you know the differences between the forms and it's written. Okay, so you've got your vector. We also have the magnitude. And let's just call this vector v. A vector is written with a little half arrow on top. Okay, so you have vector v. And we talked about the magnitude. Magnitude is simply another name for length. Can somebody tell me how would I find the magnitude of that vector? Pythagorean theorem. Horizontal and vertical components are guaranteed perpendicular. So now we're going backwards a little bit. Let's go back to SOHCAHTOA and use all that information. And so to find the magnitude, it's written like absolute value. It's equal to the square root of x squared plus y squared.
Wait, what is inside the absolute value thing?
V with the little arrow on top. It's just the name of the vector. Usually vectors take the name of u, v, w, maybe z. Okay. One other very important piece of a vector is its direction. Okay, and that's theta. We always write out the angle, and we always consider the angle as if that vector starts at the origin. Vectors do not tell me position. They tell me, well, if I'm starting at this place, where should I go from here? They're not going to tell you anything about where to start. In other words, let's say that I handed a vector out to everybody in the class right now. And I said, I want you to move, in measures of feet, the vector that I gave you. And I gave everybody the same exact vector. Everybody would start at a different location because you're all sitting in a different place in this space. But you would all move exactly the same position. So it would be like us all standing up and all moving in unison to that one place. And we would just basically shift around. Okay? So it doesn't matter where you start.
Can we try it?
Yeah, let's not. That would be funny. So let's talk about theta. Can somebody tell me how to find theta? Yes? And there's one specific one I have to use because I have x and y. Be specific. Theta is going to be tan inverse of. Good. Perfect. Y over x.
That's just SOHCAHTOA.
Yeah.
Well, I wanted you to be more specific. Because SOHCAHTOA could be sine, could be cosine, could be tangent. If I give you a vector, you don't have the hypotenuse. It would make sense. I could find it. That's the magnitude. But that takes me more work to get to the angle when I could simply do tan inverse of y over x and be done with it. Questions about that? So far we've talked about two things. Direction and magnitude. Okay? The direction is the theta. The magnitude is the length. It's the Pythagorean theorem. Let's talk about one more thing. Sometimes I'm going to give you a vector, and it's in its most. I'm going to give you points. So let's say we give you the point 1, 3, and I'm going to give you the point negative 2, 7. What I want you to do is find the vector when you find vectors from points, you have to know which point is which. Because if you're just arbitrarily, where did I start, where did I end? If I don't know that, then some of you will give me one vector, and some of you will give me the exact opposite vector. And that's two different vectors, and we don't do that. So, in order to write a vector, we have to know two things. What's the initial point, and what's the terminal point? So, we're going to call this initial, and this is going to be terminal. In order to find a vector from 2 points, it's as simple as initial minus, or terminal minus initial. Sorry. Terminal minus initial. And literally, you're going to keep the actual pieces together. So you're going to say x's go with x's and y's go with y's. If you subtracted it backwards, if you said initial point minus terminal point, then what's going to happen is your coordinates, your vector components, are going to have the opposite signs as mine, which means your direction is different than mine, which means you have an opposite vector, not the vector that I'm looking for. Okay? And so in this case, to find out the actual vector, we'll say terminal point, so this is negative 2 minus 1, and the other part's going to be 7 minus 3, which turns out to give me negative 3, 4 as my new vector. If you were to plot this 2 points on a coordinate plane and count the horizontal distance and the vertical distance from one point to the next, basically its slope, then you would get exactly negative 3 and 4. What does it mean to have a negative component here? It's telling you a direction. If x is negative, it means you go left that far. If y is negative, you go down that far.
How do you know the difference in terminal and initial?
It must be told to you, or it's
Told to you?
or visually viable. In other words, if we label this, we'll go back to our diagram. This is initial, and this is terminal.
So you know which way to draw it.
Yeah. If no one was told you, and I just simply gave you 2 points and said find the vector, that's arbitrary, and I can't mark either one of them wrong. Because I guess you could assume the first point I give you is the initial, the last point I give you is terminal. but that's still a little bit arbitrary, and I would never do that on a test situation. Okay, so you'll know one way or the other. Any questions on magnitude, direction, finding the vector from points using terminal minus initial, and what the vector's pieces are?
No.
We're good on all that. That's pretty straightforward stuff. Okay. What's wrong? Let's just do an example. Here's a vector. You have vector v. Actually, let's do point. Let's do the point 2, 1, and the point 5, -6. I want you to do 3 things. Number 1, I want you to find the vector, the component form. Number 2, I want you to find the magnitude and the direction. You'll need your calculator for this. Okay, so you can see that we've subtracted terminal minus initial to get 3, -7. We went ahead and we applied Pythagorean theorem to find the magnitude of square root of 55. And we went tan inverse of -7 over 3. Be careful there. You always have to use the vector to find the angle, not one of the original points. Okay? When I do tan inverse, tangent inverse is always going to do this. If your angle is in the 4th quadrant, it's always going to give you the negative version. In this case, we're in the 4th quadrant, so I got -66.8. Add 360 to that to get the positive angle to be 293.2.
Okay, why is it not the square root of 58?
Oh, did I add wrong? That's very possible. I was trying to do it in my head. It's 9 plus 49. No, you're right. Good call. 58. Good. Thank you.
So would you rather us put it as -66, or would you rather get the 290?
Typically, we want to stay between 0 and 360, but I'm not going to make a big deal of it. If the direction's stated a specific way, give your answers from here to here, then follow those directions. Otherwise, it's not that big a deal. But be careful. Something to note on this. What happens if my vector is in the 3rd or 2nd quadrants? Will the calculator give you the accurate representation? No, it will not. You as an individual have to think about, where's my vector located? Where is it pointing? If it's in the 3rd or 2nd quadrants, I'll have to add 180 to whatever I get. Okay? That's something that you're going to have to remember, and just to do that. Otherwise, you won't ever know that you got it wrong. Okay, let's move on to the next part. Let me clear that. So, there's 2 ways that you can pull vectors together, and we're going to do that. First, we're going to do geometric combinations, geometric computation with vectors. I don't know if you've done this in physics or not, but it's not bad at all. Let's say that this is vector u.
That's a nice arrow.
Yeah. I don't want to do that one. Let's do a short one. So that one's going to be vector v. Whoa. And let's do one more where we'll go. Let's go up like that. So on the screen, I've written 3 different vectors. Listen carefully. I'm going to tell you to add these vectors together. So let's say part A. I want you to do u plus v. Anybody know how to add vectors graphically? There's a little phrase we say. This is very easy, but if you don't know, you're kind of... Remember, are there any numbers up there?
No.
No numbers. So it's key phrase, cut and paste. That's what you're really going to be doing. But this is how you do it. It's going to really be tip to tail. You're going to take a vector, the first vector that you start with, Draw it. Wherever you ended the first vector, you're going to start the second vector. For example, u plus v would look like this. I'm going to take u, I'm going to draw u. Now I'm doing it, that's not long enough. So that's close. If I'm doing this on a test or a quiz or something, then the vectors I give you would be on a coordinate grid, and you would know exactly how far over and up or down to go. So in this case, we're estimating, so just close is good here. I'll put u down, and I'm going to take v, and I'm going to put v right at the end of u. To create the what we call resultant vector, that's basically the answer to this question. We're going to go from where we started to where we ended. And this is called the resultant. So this would be u plus v. Well, that's fantastic because this is just reviewing. In terms of graphics, that's about all we're going to do. I'm going to do one more that's a little more complicated, but it's the same stuff. No. Not this part of it. So I want you to try this one. Let's do 2u minus v plus w. I'm introducing two ideas here. I'm introducing the negative vector, or the opposite vector, which take the arrowhead, put it on the other side, and that's the opposite vector. So in fact, it's the same magnitude, but just the complete opposite 180-degree different direction. Okay? What about the 2u? What are we going to do with the 2u?
Make two of them.
I literally double its length. I make two of them. Good. Draw the resultant vector when you're done and see what you got. So you can see as you see the drawing, that's my resultant vector. Okay? Now, there's a lot of different ways that you could add and subtract. In last period they asked, well, what if we did it the other way around? It would make a difference. Now you can get the negative sign wrong. If you just switch it around and you leave the negative off, then you're going to get it backwards. But we can add in any order, correct?
Correct.
Okay? So it doesn't matter which way around you go. And what you might have is a complete opposite version of mine on the other side of the vector, resultant vector. But you're going to get to the same exact ending location. And when I do start to end, my resultant's going to be the same thing. Questions about drawing it graphically?
No.
That's about as complicated as it
Start
gets.
with W and go round off to the left, and then go negative V, and then go ultimate to U.
You'd get exactly the same location. Just be careful not to. The only caution I say about that is be careful with the negatives. If you get the negative attached to the wrong vector, then you would be going in the wrong direction. Okay? Let's see. Let's do some operations. So that was geometric. Let's do algebraic. And this is where we're going to spend a majority of our time and effort, is in the algebra part of it.
No.
Okay? Not complicated. So here we go. I'm going to give you a couple of vectors, and I'm going to ask you to do the operations, kind of like what we did graphically. But now I'm going to give you numbers. And it's really, really easy. And you're going to like this. It's multiplication, addition, subtraction.
It's not possible to like that.
Maybe not, but we'll see. So u equals -1, 3. V equals 4, 7. I want you to do the following. I'm going to do just u plus v. B is going to be 3u, and c would be 2u minus v. Do this real quick, but this time instead of drawing things, you're going to do it to the numbers at hand. Just like you naturally think, x's go with x's, y's go with y's, and you keep them separated. You don't ever mix the x and the y components together. Apply those. What do we call the 3 and the 2 here? It has a specific name. It's a scalar multiplier. It's effectively, I'm scaling it. I'm multiplying it by 3 or maybe by 1/2. I'm changing its magnitude. That's all that happens there. Your answer for all 3 of these will just be a new vector, an x comma y. And so you can see now the solutions to each one. With A, I just basically added the x's, I added the y's. With part B, it's just a scalar quantity. You just multiply the original coordinates, by 3. For C, it's a combination of all that. I had to do scalar quantities, multiply, and then I had to just subtract the 2 resulting vectors to get my -6, -1. Any questions about basic computations, either algebraically or geometrically? We're good? Okay. Let's talk about unit vectors. Okay, so this part, a unit vector, listen carefully. It's not hard either, but it's a little confusing. A unit vector is, you give me any vector. Okay? That vector's magnitude is probably not 1. But a unit vector has a magnitude of 1. That's what makes it a unit vector. Okay? And so, if we started out and we had a vector, let's say we had the vector -3, 2. Now that magnitude is what? What's the magnitude of this vector v? Good. The magnitude of vector v in this case is the square root of 13. That's definitely not 1. So the questions would be like this. On a quiz or test or whatever, I want you to give me a unit vector that is the same direction as the original vector. So what I'm really telling you to do is I want you to scale back my magnitude back to 1. So you need to know what are you going to divide by to get that scale backwards, or multiply by, depends on which way you're going, to go backwards and make sure that length is 1. Real simple operation. And this is your, so we'll call it u as a unit vector. You take the vector v and you divide the vector by its magnitude. So that's the, and let me just show you. It's really simple. It's 3 over the square root of 13, comma, 2 over the square root of 13. I mean, it can't get much easier than that. Now, of course, if you can simplify the square root of 13 and simplify that fraction, you want to go ahead and do that. But if you were to go here and calculate the magnitude using Pythagorean theorem, you would find out that it would be exactly 1.
What's wrong with -1, 0?
It's not in the same direction. -1, 0 is in 180 degrees. This vector goes up into the second quadrant. So having a unit vector on one of the axes is a big deal, and it's going to be, it has a name. It has I, J, and if we go 3D, K. So for X, Y, and Z axes. We'll call those, we'll talk about those, we'll go 3D, not this chapter.
So,
But those are reserved for special situations.
you need to get the, like, is that how you write it?
Yeah, you're done.
You don't have to get the round.
This is the unit vector.
You don't need to carry it out.
Nope. I mean, you can. I'm not going to make you do it. Okay? A lot of the times you'll find out that the radical, like you'll get square root of 16, and you'll end up dividing by 4, and it'll work out to be a nice fraction, no big deal. Okay. One more big piece, and let's clear. Sometimes I'm going to give you the actual pieces of the vector. I'm going to tell you the direction and the magnitude. I'm going to give you angles. I'm going to give you the magnitude, how long it was. But then I'm going to say, what's the vector to start with? What's its x and y components? Okay. So now you got to go backwards. And so everybody already knows how to do this. Since this is how my vector looks, if I told you the magnitude and I told you theta, what we want to find is the x and the y parts. So here it is. X equals, judging from that particular triangle, can you tell me a formula to get x? Almost. Think about it. X equals what?
No.
X is related to cosine. Okay? If my magnitude was 1, then x would be cosine, right? Just like the unit circle. What do you think y is?
Wait, why is it the magnitude times the unit?
Because we're not on the unit circle. Think about it. Look at the angle. Watch this. It's going to be sine of theta equals y over the magnitude of v, right? Can you solve that for y? Which gives you directly that. And magic happens.
You read that on my test.
I know, right?
What?
She did some magic and poof, the answer showed up. And I don't know how she got to the answer, but...
It was right.
Okay, let's review real quick. Okay, we talked about a number of things. We talked about finding a vector from points, terminal minus initial. Right, Allison?
Yes.
Okay, number 2, we talked about finding its magnitude using Pythagorean theorem. 3, we talked about finding the direction, the angle of the vector, which is tan inverse of y over x. We talked about writing it in vector form versus just a regular point with the pointed brackets. Don't forget about that. We talked about graphing geometrically, adding tip to tail. Never tail to tail or tip to tip. Never add the same thing together. You're going to get messed up. Adding algebraically, multiplying with scalars, adding and subtracting your like pieces. We talked about finding unit vectors. Shh, listen. Unit vectors found simply by dividing a vector's components by its magnitude. And last, we talked about the component form. If I give you the magnitude and direction, can you work backwards to give me the x's and the y's? Okay. The last thing we're going to talk about is your homework, which is right here. So page 511, 3 through 27 multiples of 3. Just make sure that you take those out. It's pretty straightforward stuff. A lot of what we talked about today is what your homework is about. If you need to watch this video, it'll be online.